Hello there. Actually, I should probably go this way. Hello there. I'm Lucas. That was really weird. You already know who I am. This is my physics project. I'm going to be covering Newton's 3 laws of motion. This is 3 fingers. Yes, good. I'm going to have an introduction, which I'm doing now. First law, second law, third law, conclusion. I'm going to be doing 10, so I'll do 1 for the first law, 1 for second law, 1 for third law, just talk about what they are and identify and describe. That's my first 3, and then I'll do 2 physical for each. So that's why I have a pool table here, the Denver Broncos ball, because we're playing today, and it's also just cool. So yeah, I'll do 2 for each, for the first law, for the second law, for the third law. And then, actually that's 9, my math isn't working. I might just do another one for the third law because I like hitting balls with a stick. You want to see my stick? Where is my stick? My stick is right here. This is my stick. Anyways, we're going to continue on. This will not be cut out because I don't know how to edit videos. I'd love to learn how to. Anyways, first law. Yeah. Alright. First law. An object is in motion. An object stays in motion. When it is in motion, an object stays at rest while it is at rest, unless acted on by an outside force. So, take this cue ball for example. This is a cue ball. Actually, it's a really nice one I got for Christmas a few years ago. Anyways, it's set down here. It's in rest. It's not going anywhere because it is in rest. Now, it's going to stay in motion and it eventually stops because there's friction on this table and there's gravity affecting it. But the basic idea is that it is at motion while it's in motion. The second law, I'm getting distracted because I have a pool tutorial on over there for some 2017 pool championship. Chris Mellon did this huge run out. It's going to be one of the most watched pool games. I don't know why I'm bouncing, and I don't know why I'm telling you this. Alright, number 2. Here's second law. Let me, 1 second. Okay, I just have to look it up because this one has confused me. But let me take off the triangle and hopefully everything, yes, it stays together. You don't know how long I've been trying to do that normally. They just roll off because the sticker is not in place. Anyways, second law. Alright, the second law is the acceleration acting on an object. So let's say, again, this cue ball is equal to the net force acting on the object, and again, the cue ball. I roll it into the pocket. The acceleration is equal to the gravity, the friction, the normal force of this here table, and the force of me pushing the ball across. And in this case, my force initially out over, what's the word I'm looking for? Overcame, it was more powerful than the friction force and the gravity force. So that's why it was still moving. But if I don't push it at all, or actually as it slows down, then my force dissipates. And there is, at that point, my force has decreased so much that the gravity and friction are stronger on it than the force I applied to it. And it's just gonna slow down. It's also transferring energy here, which we can talk about later in a separate video when I've actually learned how to talk about that. But yes. All right, third law, action and reaction. Kind of basic. For every action, there's an equal and opposite reaction. If I want to punch this painting, It's gonna hurt like hell, but that's one reaction of it. The other reaction would be my dad would be really upset because he loves this stuff. So, and actual, now we move on to the physical stuff. I'm going to break this triangle of pool stuff up, and I really hope I don't whip it because I haven't played in a while. But my action is pushing this. That was not supposed to happen. If I could put in the blooper beep, I would. We'll just call it there. We'll just call it good. My action is going to be the force applied on this, going into this mass of masses here. I don't know if that's even a statement that I could say in physics. It probably is. But anyways, yes, I did just kick a stool. No, nothing went in. Dang it. Normally stuff happens here. That's okay. So, yes. Action, reaction. Let's say, it'd be really cool if I did cheat and made this in. Action, I hit this ball. Reaction, this is going to bounce off. It's probably going to go left or right, if I'm going to be honest here. And then it'll probably go forward and to the left if I cut it into this wall, or if I cut it too hard and it goes over here, or if it cuts here, this 3 ball is going to go like this, bounce out over here. I'm going to screw myself out of a pocket and probably end up somewhere over here if I hit it too far on the right side. But it'd be really freaking neat if I could line it up, hit it in the center. So that's what we're going to try and do. Action, reaction. It works, forward and right side. So, yes, thank you for listening to my TED Talk. So that's about 7 minutes. So, oh, am I working backwards or forwards? I think I kind of lost track, but first law of inertia. This thing is going to stay in motion unless acted on by an outside force, in this case colliding with the ball, or gravity and friction, which are always at play here. This is a 30-year-old felt, so not in the greatest shape. If I would slam it into 3, it's probably going to hit 4, if I'm being honest with you. Slam it into those. It's going to stay in motion. The inertia from my initial applied force, assuming it was frictionless, it would have continued on forever. And it probably would have hit this uneven groove here, gone flying off, and broken my dad's framed work gift thingy. Second law, acceleration is equal to the net force. This thing is going to be traveling however fast it's going to be traveling, but the instantaneous acceleration is equal to how much force I had to put on it. Once again, like throwing a punch, and I am out of the camera view. Whoops. And now my head is cut off. I'm just going to sit over here. And then third law, every action has an equal opposite reaction. Is there anything else I'm going to say? Action, I'm going to push this ball forward. It's going to bounce off this wall, and it's going to bounce back over here. Or I'm going to apply spin to it, and it's just going to rotate back, or it's going to do something interesting. Excuse me. So action, I'm applying force here. Reaction, it bounces. And I applied some left spin on that so it didn't continue its way up the table, it continued leveling out, which is something that's really fun to play with. So you can do stuff like have it work its way down. I almost at rank Q, that was a bad idea. Anyways, once again, thank you for listening to my TED Talk. Can I get over here without losing myself? I can. Cool. As my project. I'm Lucas. Goodbye.